Alright, in Chapter 8 class, we're taking a look at systems of equations. And we have looked at systems of equations in Pre-Calculus and Foundations 10, where we looked at systems of linear equations, and so I just want to review what a system of equations is. Alright, at its heart, when you have two equations, for example, y is equal to x plus 1, that's a line, and y is equal to negative 2x minus 1, that's another line. You get two graphs. Right, so y equals x plus 1 has a graph that looks something like that, and y equals negative 2x minus 1 has a graph that looks something like that. And you'll notice those two graphs cross at one point. Right? The point where those two graphs cross is the solution to the system of equations. And in this chapter, we're going to be looking at systems of equations, except for they're not going to be just lines. We're going to have systems of equations which involve a line and a parabola, and systems of equations which involve two parabolas. One of the things that you might notice about these systems is that a line and a parabola, they might cross twice, and similarly two parabolas might cross twice, in which case you would get two solutions to your system. Those aren't the only options. We'll look at some of the other options later on in the video. One of the reasons that mathematicians take a look at systems of equations is that sometimes they occur in real life. Let's take a look at example 1. It says two divers start their dives at the same time. One diver jumps from a 1-meter springboard and the other jumps from a 3-meter springboard. Their heights above the water are plotted over time. A. Which system could model this scenario? Explain your choice. Tell why the other graphs could not model this situation. And B. Explain why there is no point of intersection in the graph you choose.
McNinch, can you go to the canteen, please? Val McNinch to the canteen.
All right. Let's address A. Which system could model this scenario? Explain your choice. The first thing I know is that one diver is jumping from a higher point than the other diver. If you take a look, for example, at system A, when the time is 0, we've got one diver, I don't know, looks like about 1 meter off the ground, and a second diver about 3 meters off the ground. Maybe that's the system of equations that models this solution. If you look at system B, we've got one diver starting at a height of 0 and the other diver starting at a height of 3. All right, that's two divers starting at different heights. Maybe that's our system. If you take a look at system C, we've got both of our divers starting at a height of 0. That's probably not our system. And if you take a look at system D, again, both of our divers would be starting at a height of 0. So D is probably not our system. If I was going to choose which system could best model this scenario, I would choose system A. Right? System A has one diver starting at a height of 1 meter, jumping up, and then hitting the water. The second equation in the system has the diver starting at about 3 meters, jumping up, and then hitting the water a short time later. So which system could explain this scenario? All right, system A. I chose system A because it has two divers starting at 1 and 3 meters. Right? Why the other graphs could not model the system? Let's see. Right, system B. One of the reasons I didn't choose system B is that one of the divers started with a height of 0. And that's not what the question said. Right? System C. Well, system C has both divers starting with a height of 0. And the story says that they started on a 1 meter board and a 3 meter board. And finally, system D, again, has both divers starting with a height of 0. Alright, so you need your system to accurately model the situation that you're going into. And that requires carefully reading the story and deciphering what information is being given to you. Question B says, explain why there is no point of intersection in the graph you choose. Well, a point of intersection would mean that the divers were the same height at the same time. All right, so a point of intersection would mean the divers are the same height at the same time. Right? But they're both acting under the influence of gravity. So if they start out at different heights, as they fall at the same rate of acceleration, which means that they would never be the same height at the same time because they started at different heights. Alright, so both are falling under gravity's acceleration. And so they can't pass each other. All right? So a system of equations is a system in which you have two graphs. Any solution to the system are where the two graphs cross.